Hi students, welcome to the part 1 PYQ discussions of the chapter functions. Okay, in this video we will be discussing questions from 2024 and 2025. So many questions will be discussed. Along with that, the concepts and shortcuts will also be elaborated. Okay, so in this video we will be discussing questions from domain and range, composition of functions, one on to into functions like that. Okay. So, it will be a video which is very helpful for you for the upcoming examinations. So, stay tuned for the last question. Okay, let's start. So, our very first question, okay, a function is given like f of x is equal to 6 plus 16 cos x into cos pi by 3 minus x into cos pi by 3 plus x into sin 3x into sin 6x. Okay. And the range of the function is like closed interval alpha to beta. Then you need to find the distance of the point alpha beta from the given line 3x plus 4y plus 12 is equal to 0. Okay. So, a question which is combined in functions as well as from 2D geometry. Okay. So, let's start. See, we need to start from here. Okay. We need to start from the given expression here. Okay. Let's formulate it. That is f of x is equal to 6 plus 16 into, okay, see, have you seen this anywhere? Cos x into cos pi by 3 minus x into cos pi by 3 plus x. There is a formula actually. The formula is like this, cos theta into cos 60 minus theta into cos 60 plus theta, which is equal to cos 3 theta divided by 4. Okay, that's a standard formula. The same formula goes for sine also. Sin theta into sin 60 minus theta into sin 60 plus theta is equal to sin 3 theta by 4. And for tan, it will be like tan theta into tan 60 minus theta into tan 60 plus theta is equal to just tan 3 theta only. Okay. So, here we can apply this formula, right? Instead of theta, we have x here. Therefore, it will be 16 into cos 3x. Okay. By 4 into sin 3x into sin 3x into cos what? 6x. Okay. So, listen very carefully. This 4 and this 4 got cancelled. This will be 4 here. I am writing it as 2 into 2. Okay. So, what will be 2 cos 3x sin 3x? What is the formula for sin 2 theta? Sin 2 theta is equal to 2 sin theta cos theta. So, what is the formula for sin 2 sin 3x cos 3x. Okay, that is sin 6x. Therefore, it will be like 6 plus 2 into 1, 2 is here into sin 6x into cos 6x. One more time you can apply this formula. What is 2 sin 6x into cos 6x? That is 6 plus sin what? 12x. Okay. So, this is what the function f of x is. So, the expression has reduced from this to this 6 plus sin 12x. So, how will you find the range of this? It is very easy actually. See, we need to move to the next slide. See, the value of sin 12x lies between minus 1 less than or equal to sin 12x less than or equal to what? 1. Okay. I think we have 6 plus sin 12x here. Okay. Therefore, add 6 everywhere. You will get 5 less than or equal to 6 plus sin 12x less than or equal to what? 7. Okay, so this is the range, that is closed interval 5 to 7 is the range of the given function. Okay, therefore we need to find the distance from this point to the line 3x plus 4y plus 12 is equal to 0. Okay, 3x plus 4y plus 12 is equal to 0. So we can use distance formula from here, that is 3 into 5, modulus of d will be 3 into 5 plus 4 into 7 plus 12 divided by root of 3 square plus 4 square. So, this will be 15, this is 28 and this is 12. Okay, that is 40, 55. 55 by this is 5, that is 11 is the final cut answer for this one. Okay, I hope you got the idea here. Okay, that is option number 1. This is the correct answer. Okay, I hope you got the idea here. Okay, was a very easy question. And let's move to the next one, next question. Okay, that is question number 2. Okay, two functions are given. Okay, f of x and g of x, where f of x is equal to log x to the base c and g of x is equal to x raised to 4 minus 2x cube plus 3x square minus 2x plus 2 divided by 2x square minus 2x plus 1. Okay, then you need to find the domain of f of g. Okay, let's find f of g first. So, f of g will be f of g of x will be log of x raised to 4 minus 2x cube plus 3x square minus 2x plus 2 divided by 2x square minus 2x plus 1. Okay, see, we know that the domain of log is should be greater than 0. Okay, we cannot substitute a value which makes it negative. Okay, so if you consider it like this, base e here, let's take it as p. That is, instead of this, I am writing it like this, log p to the base e. So in this case, p should be what? Greater than 0. Okay, only then it will valid. Okay, therefore we can equate it like this. That is x raised to 4 minus 2x cube plus 3x square minus 2x plus 2 divided by 2x square minus 2x plus 1. It should be greater than 0. So how are you going to formulate this one? It's very easy actually. It's not as complicated as it looks. Okay. So here we have numerator as well as denominator. In denominator we have a quadratic expression, right? That is 2x square minus 2x plus 1. Okay. So what is the discriminant of that quadratic equation? Discriminant will be minus 2 the whole square minus 4 into 2 into 1. Okay, this is 4, 4 minus 8, that is negative, right? So discriminant is what? Discriminant is negative. So this quadratic equation will not have any roots, real roots. Okay, that's another thing. See, if the discriminant of a quadratic equation is negative, then for whatever value of the variable of the quadratic equation, it will have the same sign as the coefficient of x square, coefficient of the second degree variable. Okay, so here the coefficient of second degree, the sign of coefficient of second degree variable is what? Positive. Okay, so whatever the value of x you substitute here, you will get a positive value. Okay, and if somehow if it is negative, then for the same condition, whatever the value of x you substitute here for in this quadratic expression, you will get a negative value. Okay, that is the nature of the topic regarding nature of roots of quadratic equation. Okay, I hope you got the idea here. See, fortunately it is like this. So it will save a lot of time here because we don't have to mind about this quadratic expression because already it is positive. Okay, so to make this numerator and denominator positive, numerator should be what? Positive. Otherwise, there will be two cases like numerator and denominator should have a same sign. Therefore, either both of them should be positive or both of them should be what? Negative. Okay, in this case, already the denominator part is what? Positive. So the numerator part should be greater than 0. Okay, I am going to use the next slide to solve this. That is x raised to 4 minus 2x cube. X raised to 4 minus 2x cube. Okay, plus 3x square minus 2x. Plus 3x square minus 2x plus 2, right? Plus 2. Okay, plus 2 should be greater than 0. Okay, we need to find the set of values for x for which this is greater than 0. So, it's a quadratic equation. How are you going to formulate it? It's very easy actually. Let's assemble some terms here. That is x raised to 4, 3x square and 2. I am going to assemble this and it will be like x raised to 4 plus 3x square plus 2. Okay. Minus 2x cube minus 2x, that is greater than 0. I hope you are getting the idea here. Have you seen this anywhere? X square plus 3x plus 2. You have seen that, right? X square plus 3x plus 2. That can be factorized as x plus 1 into x plus 2. Like that, this can be factorized like x square plus 1 into x square plus 2. Okay. If you take minus 2x outside, it will be minus 2x into x square plus 1. That should be greater than 0. I hope you are getting the idea here. Okay, what should we do next? Consider these two as common. That is x square plus 1 into x square minus 2x plus 2. Okay, that is greater than 0. Okay, so this will always be what? Positive. Square of a number is non-negative, plus 1 will be a positive number. So we need to formulate this one. Okay. So the discriminant of this quadratic equation will be negative. Okay, that is minus 2 the whole square minus 4 into 2 into 1, that is negative. Okay. So for whatever the value of x, this value of x, the values which you substitute here for x, the sign of the values obtained will have the same sign as the sign of x square here. Therefore, here the sign of x square is what? Sign of coefficient of x square is what? Positive. So for whatever value of x, it will be positive. So this is positive. This is also positive. So positive into positive is what? Positive. Therefore, for whatever the value of x, this expression is what? Positive. Therefore, we can substitute any value for x. Okay. Therefore, what is the domain here? Domain is real numbers. Therefore, this is at the domain of f of g of x is what? Real numbers. We can substitute any values. Okay. Hope you got the idea here. Moving to the next question. So, our very next question. Okay, a function is given like f of x minus 6 into f of 1 by x is equal to 35 by 3 into x minus 5 by 2. Its domain is real number minus z0, that is all real numbers except 0, and domain range is real numbers. And another a limit is given along with its final answer, that is limit x tends 0 1 by alpha x plus f of x is equal to beta. Then you need to find alpha plus 2 beta, that is basically you need to find alpha and beta. So all of you should know how to solve this equation. Okay, it has been asking for ages. Okay, since a very long time a question regarding an equation regarding this has been asking. Okay, so we can solve it like I'm going to write this one time, that is f of x minus 6 into f of 1 by x is equal to 35 by 3 into x minus 5 by 2. Okay. See, we already have an equation containing f of x and f of 1 by x. Okay. If you have one more equation which has f of x and f of 1 by x, then we can easily solve that using elimination method or whatever method we are familiar with. Okay. So, what I am going to do is, I am going to introduce another equation which has f of x and f of 1 by x. So, how are we going to obtain that equation? Another equation which is having the same structure by using this one. It's a very easy question actually. See, there is a substitution like put x is equal to 1 by x. If you put x is equal to 1 by x, the equation will be like f of 1 by x minus 6 into f of x is equal to 35 by 3 into x minus 5 by 2. Okay, I am rearranging this here, that is it will be minus 6 into f of x plus f of 1 by x, which is equal to 35 by 3 into x minus 5 by 2. Okay. So, we need to cancel this one, right? F of 1 by x. So, multiply here with 6 and add it, and you will get minus 36 into f of x plus 6 into f of x is equal to, this is 70x, right? 70x or okay, 70x minus 30 by 2, 70x minus 30 by 2. Okay, just add it and you will get this and this will get cancelled, that is minus 35 f of x minus 35 f of x is equal to 35 by 3x, 35 by 3x minus 5 by 2 plus 70x minus 30 by 2. Okay. So, okay, the one more step we can perform it on the next slide, that is minus 35 f of x is equal to minus 35 into f of x is equal to 35 by 3x plus 70x. 35 by 3x plus 70x, okay, and minus 5 by 2 minus 30 by 2 minus 35 by 2 minus 35 by 2. Next thing we can cancel LHS and RHS with minus 35, you will get this one like minus 1, this is minus 2 and this is plus 1. Okay, it will change to minus 1. So, it becomes f of x is equal to minus 1 by 3x minus 2x plus 1 by 2. Okay, I hope you are getting the idea here. And we have limit x tends to 0. Okay, what was that? 1 by alpha x. That is 1 by alpha x plus f of x, right? That is minus 1 by 3x minus 2x plus 1 by 2, that is equal to what? Beta. Okay. So, beta is a finite number. So, the problem with this one is, see, if limit x tends 0, if these two terms are there, then the denominator will have 0, then this becomes a not defined value. Okay. That is not applicable in this case. Okay, that can happen in cases, but not in this case. They have already stated that beta is a real number. Okay, so what we can do is we need to make alpha as a number such that this and this will get cancelled. Okay, so what is a particular number that alpha can take? Therefore, these two terms got vanished. That is, alpha is equal to what? 3. Only then these two terms will get vanished, and then it becomes limit x tends to 0 minus 2x plus 1 by 2. This will be 0 and which is equal to beta. Therefore, beta is equal to what? 1 by 2. You need to find alpha plus 2 beta, right? That is 3 plus what is 2 beta? 1. That is 4 is the final cut answer for this one. Okay, a very easy question. Option number 3. Okay, and doable also. And next one. Okay, like the previous one, this question is also been asking for so many times. A PYQ from JEE Advanced. Okay, a very easy question, and it is been keep repeating on every sessions. Okay, at least 1 or 2 questions will be there. Okay. F of x is equal to 2 raised to x divided by 2 raised to x plus root 2. And you need to find k is equal to 1 to 81 f of k by 82. That is, you need to find, we can write here, that is f of 1 by 82 plus f of 2 by 82, okay, plus etc. plus f of 81 by 82, f of 81 by 82, a term just before that will be f of 80 by 82. Okay, it will be like this. So, you need to find f of 1 by 82 till f of 81 by 82. Okay, practically it is impossible. Okay, therefore, we cannot substitute all of these values individually and find the final cut answer. That is very difficult and will be a very tedious process. Therefore, we need to formulate something here. So, for these types of questions, I will tell you a shortcut here. Just add this and this. What are you getting here? 1 by 82 plus 81 by 82. That is 82 by 82. That is, take it as A and this as B. What is A plus B here? 1, right? Okay. Therefore, what is B? 1 minus A. Okay. That is, it is f of 1 by 82 and it is f of 1 minus 1 by 82. Okay. Therefore, this is the relation between the term here and here. Also for term here and here as well. This is f of 2 by 82 and this will be f of 1 minus 2 by 82. Okay. So, if we generalize it like this, what will be f of x plus f of 1 minus x? What is the value of f of x plus f of 1 minus x? See, f of x means a value in here and f of 1 minus x means a value from this end. Okay. F of x means a value from this end, f of 1 minus x means a value from this end. Okay. And let's sort it out. What is f of x? That is 2 raised to x divided by 2 raised to x plus 2 raised to 1 by 2 plus what is f of 1 minus x? 2 raised that we need some simplifications there, therefore we can sort it out here. 2 raised to 1 minus x divided by 2 raised to 1 minus x plus 2 raised to 1 by 2. Okay. This is 2 by 2 raised to x. This is also 2 by 2 raised to x. That is 2 by 2 raised to x divided by 2 plus 2 raised to 1 by 2 into 2 raised to x divided by 2 raised to x. Got cancelled and becomes 2 by 2 plus 2 raised to 1 by 2 into 2 raised to x. So, how will you operate this 2? I hope you got the idea till here. Okay. So, let us do one thing. Our objective is to make this a finite value. Okay, so a value which we can operate and which will also ease the problem. Okay, therefore, what we can do from here is, here we have 2, here also we have 2, here we have root 2. What if we can cancel root 2 from numerator as well as from denominator? So, if you cancel, divide numerator and denominator with root 2. That is, it will be 2 raised to x divided by 2 raised to x plus 2 raised to 1 by 2 plus, what is 2 by root 2? Root 2 divided by here 2 by root 2 plus 2 raised to x. Okay, so this is 2 raised to x plus root 2 divided by, denominators are same. Okay, I wrote here as 2 raised to 1 by 2 and here as root 2. See, both are same. Therefore, it will be in the next slide, that is 2 raised to x plus root 2 divided by, both of them are same, that is we can write it like 2 raised to x plus root 2, that is equal to 1. So, practically f of x plus f of 1 minus x will be equal to what? 1. Okay. So, again we need to write the functions here like f of 1 by 81 plus f of 2 by 81 plus etc. plus f of 81. Okay, I think it's still 81, right? Okay, 81 and 80, that is f of 80 by 82 plus f of 81 by 82. Okay, you will get an interesting answer here. That is, if you club these two, if you sum it up these two, you will get answer as 1. That is 1 by 81 and 81 by 82 will produce 1. Okay, like that 2 by 81 and 80 by 8. Okay, 82. Okay, sorry. 1 by 82 and 1 by 81. Okay, if you sum f of 1 by 81 plus f of 81 by 82, result will be 1. Like that, 2 by 81 and 80 by 2 by 82 and 80 by 82 will be equal to 1. Okay, so many pairs will be there. Okay, we can formulate 3 by 81, 79, 3 by 82, 79 by 82 like that till this one, that is 40 and 42. Okay, 40 by 82, 42 by 82. Okay, how many pairs are here? 40 pairs are here. Therefore, the sum will be equal to what? 40. Okay, and if you observe closely, there is one term which is missing. Which is that term? 41. Okay, that is 41 by 42 is missing. Okay, I haven't operated for that. Therefore, what will be 41 by 42? That is, see, 1 by 82, 2 by 82 up to 40 by 82 will have a corresponding pair, but 41 by 42 will not have a corresponding pair. So, that will be an odd one out. So, the final answer will be 40 plus f of 41 by 82, that is f of 1 by 2. Okay. So, what will be f of 1 by 2? F of 1 by 2 will be 2 raised to 1 by 2. Okay. 2 raised to 1 by 2 by 2. Okay, sorry, I need to check that again. 2 raised to 1 by 2 plus 2 raised to 1 by 2 plus 2 raised to 1 by 2. This is 2 into 2 raised to 1 by 2. Therefore, the answer is what? 1 by 2. So, our net answer is 40 plus 1 by 2, that is 81 by 2. I think option D is the correct one. Yeah, option D is the correct answer. Okay, 81 by 2. Okay, I hope you got the idea here. Okay, very basic question and a usual question, a regular question from the PYQs. Okay, and next one. Okay, the question is somewhat similar. Okay, the concept is same. See, f of x is equal to 2 raised to x plus 2 plus 16 divided by 2 raised to 2x plus 1 plus 2 raised to x plus 4 plus 32. Okay, then you need to find the value of 8 into f of 1 by 15 plus f of 2 by 15 plus f of 3 by 15 etc. up to f of 59 by 15. Okay, like the previous question, but I think there is a slight change here. Okay, we can formulate this later. Let's operate this one first. Okay, let's try and figure it out. Is there anything we can do to simplify this one? Okay, let's start from here. F of x is equal to, this can be written as 2 raised to x into 2 square, that is 4 into 2 raised to x plus 16 divided by 2 raised to 2x into 2 plus 2 raised to x into 16 plus 32. Okay, just cancel 2 from the numerator and denominator and you will get f of x is equal to, that is 2 into 2 raised to x plus 8 divided by, this will be 2 raised to 2x plus 2 raised to x into 8 plus what? 16. Okay. take 2 outside, that is f of x is equal to 2 into 2 raised to x plus 4, right? Divided by, have you seen this anywhere? 2 raised to 2x plus 8 into 2 raised to x plus 16. Is that a perfect square? That's a perfect square, right? That is 2 raised to x plus 4 the whole square. Okay, it is a perfect square. Okay, we can cancel this and you will get f of x is equal to 2 by 2 raised to x plus 4. That is the value of f of x. Okay. So, unlike the previous question, in the previous question, if you add the numbers from here and here as well, you will get a value 1. Okay. But I think that's not the case here. If you add 1 by 15 plus 59 by 15, that is equal to 4, right? Okay. And again, 2 by 15 plus 58 by 15, that is 60, that is also 4. Okay. Therefore, in here it is like x plus y is equal to 4. Therefore, y is equal to what? 4 minus x. Okay. So, if it is x, it should be what? 4 minus x. That is the general expression. Okay. So, we need to formulate what is f of x plus f of 4 minus x. Okay. So, in the next slide, that is f of x plus f of what? 4 minus x. So, what is f of x? F of x is 2 by 2 raised to x plus 4. That is 2 by 2 raised to x plus 4, right? Okay. Plus this will be 2 by 2 raised to x minus 4, 2 raised to 4 minus x plus 4. Okay, then we need to sum it up. So, it will be 2 by 2 raised to x plus 4 plus this will be 2 raised to 4 by 2 raised to x, that will come here, that is 2 into 2 raised to x divided by 2 raised to 4 plus 4 into 2 raised to x. Okay, hope you are getting the idea here. So, it will be 2 by 2 raised to x plus 4 plus this will be 2 raised to x divided by, and this is if you cancel 2, it will be 8 plus 2 into 2 raised to x. Okay. And okay, here also if you multiply with 2, I think the denominator becomes same, right? That is 2 into 2 raised to x plus 8. Therefore, it will be 2 raised to x, okay, plus 4 divided by 2 into 2 raised to x plus 4, right? That is, it is also 2 into 2 raised to x plus 4, got cancelled. That is, f of x plus f of 4 minus x is what? 1 by 2. Okay, that's done. We need to formulate things here for next. Okay, that is the numbers are like, I am writing the numbers only 1 by 15, 2 by 15, 1 by 15, 2 by 15 till 58 by 15, 59 by 15. Okay, assemble the corresponding pairs. It will be 1 by 15, f of 1 by 15, f of 59 by 15, their sum will be equivalent to 1 by 2. Like that 2 by 15, 58 by 15, sum will be equivalent to 1 by 2. How many terms will be there? Okay, that is 29 by 15, 31 by 15, that is also equal to 1 by 2. So, how many terms are here? 29 terms are here, 29 pairs are here, and each of the sum is equal to 1 by 2. So, total sum is what? 29 by 2. Okay, plus there is one term which is missing. Which is that term? F of next term is what? 30 by 15. So, what is 30 by 15? F of 30 by 15 is f of 2. Okay, plus f of 2. Okay, and what is f of 2? This is f of x, right? F of 2 is 2 by 2 square plus 4. Okay, that is 2 by 8, that is what? 1 by 4. Okay, so the net result will be 29 by 2 plus 1 by 4. Okay, and if you cross multiply it, you will get, I am cross multiplying it here, the value I can write it here, that is 118 by 8. The value will be 118 by 8. So, that is what the sum is, but I think you need to find 8 times of that value, right? That is 8 times of that value. Therefore, 8 times of that value will be 118 itself. Okay, I hope you got the idea here. Okay, was similar questions, but in most of the questions, the numbers, the sum of the corresponding numbers from the first end and the last end should be was equal to 1, and sometimes they will go for other values also. Okay, and this question the difference is like we need to formulate here also. Okay, to a we need to reduce this expression also. Okay, to make things more easier. Okay, and that's all. Hope you are getting the idea here. Let's move to the next question. Okay. Okay, the number of real solutions of the equation x square plus 3x plus 2 is equal to minimum of set of mod x minus 3 comma mod x plus 2. So, how are you going to formulate this one? Easy. See, this can be written like x square plus 3x plus 2 can be written like x plus 2 into x plus 1. Okay, I am writing it like that. This will be a parabola. Okay, x square plus 3x plus 2 will be a parabola. We can do later. We need to formulate this one first. Minimum of mod x minus 3 comma mod x plus 2. Okay, let's start from a figure here. Okay, and this is okay, take it as y axis. Okay, so this is point 3 and this is point minus 2. The graph will be like, one will be like this. Okay, and what will be the next graph? One will be like this, and the next will be like before that I need to solve it. But I don't know whether in which quadrant they are intersecting. Either it will be like this or it will be like this. For that we need to solve this one. Okay, so this will be mod x minus 3. In here it is x is greater than 3. Therefore, this will be x minus 3 and this will be 3 minus x, and this will be minus x minus 2, and if it goes here it will be x plus 2. Okay, therefore we need to find the point of intersection of x plus 2 and what? 3 minus x, that is 2x is equal to 1, right? That is x is equal to 1 by 2. That means in quadrant 1 it will be like this. Okay, pardon my drawing here. Okay, x is equal. Okay, x is equal to 1 by 2 in here. Then we need to formulate the minimum of mod x minus 3 and mod x plus 2. That we can write like this. Okay, so in here in this region, which one is minimum? Okay, compare. See, it is when it is more than 3. Just draw a line here. 2 lines are here, which is minimum. This is the minimum one. Okay, I am drawing it with the white marker here. Okay, so between 0 and 3, which is the minimum value? Between 0 and 3, there are 2 lines. Okay, which is producing the bigger value. This is producing the bigger value and this is the lower value. See, there is a technique actually. Okay, just if you want to point out which one is minimum, just mark a point here. Just take the point as 1. Okay, then draw a vertical line from 1. Okay, so this function produces a value towards here and this function produces a corresponding value here, which is maximum. This line is producing the maximum value and this is producing the minimum value. That is how you find the minimum and maximum. Okay, I am removing this. Okay, we need to formulate other things here, that's why. Okay, so in here this is the one, and in here I think 2 are there. Bigger one is this one. Okay, smaller one is this one, sorry, and comparing these two, again this is the minimum one. So a shape like W. Okay, it is where the minimum of this one. Now we need to draw the graph of this one. So x square plus 3x plus 2. How will you formulate x square plus 3x plus 2? Easy actually. X square plus 3x plus 2. Just put f of x is equal to x square plus 3x plus 2. There is no need of that actually. And what is f dash of x? F dash of x is 2x plus 3. 2x plus 3 means its slope is in minus 3 by 2. Okay, the tangent to the base will be minus 3 by 2. Therefore, minus 3 by 2 will be here. Okay, therefore, it will pass through the point and it will pass through the point minus 1 and minus 2. Minus 2 is already here. Here we have minus 1. Okay, so either the parabola will be like this or will be like this. So, it will be opening upwards. Why? Because the slope of the tangent is 0 where x is equal to minus 3 by 2. If you equate this to 0, the slope of the tangent of the parabola is 0 at the point where x is minus 3 by 2. That will be in here. Okay, so the parabola will be like this. From here and it will cross here. From here, that we need to check it out. Okay, whether it is crossing which point. Okay, so let's take the point where the parabola hits the y-axis. the parabola hits the y-axis where x becomes 0. Okay, that is 0, 2. Okay, the parabola hits the y-axis at 0, 2. And let's check if any one among these two, okay, there are 2 points here. This is point number 1 and this is point number 2. Let's check if any one among the 2 points pass through the point 0, 2. Okay, only then we can draw that. Okay, let's take this one. Okay, this is mod x plus 2. Okay, if x is equal to 0, this line passed through the point 0, 2. This is the point 0, 2, right? See, this is what mod x, the graph of mod x plus 2. Okay, the graph of mod x plus 2 hits the y-axis when x is hits the y-axis, then x will be 0. Then what is the corresponding value of y? 2. Therefore, this point will be what? 0, 2. Therefore, the parabola passed through this point. Okay, so it will goes on like this and towards here. So, how many points does the parabola cuts the corresponding minimum value of these two modulus? 2 points, right? One is among here and one is among here. Okay. Therefore, how many solutions are here? 2 solutions are here. Okay. See, there are another algebraic methods for solving this one. Okay, but I have not gone for this one because graphical method is more easy. That's why. Okay. See, for detailing, it requires much time. But if you understood the concept very well, and if you try to solve problems using graphical method, it becomes more easier. Okay, see here I am going to explain, I have to explain things, otherwise you won't be able to understand. But if you understood the concept very well, and if you apply the concept and solve the questions using graphical method and all, then it won't take much time. Okay, I hope you got the answer here, so the concept here. Let's move to the next question. A function is given, the domain is real numbers and the codomain is from -1 to 1. Okay, given by f of x is equal to 2 raised to x minus 2 raised to minus x divided by 2 raised to x plus 2 raised to minus x. We need to identify whether the function is injective or surjective or like that. Okay. So, about this question, there are 2 methods to this one. Okay, the first method is the method which is discussed in your school. Okay, for to identify whether the function is 1, 1 or many 1, just formulate the function like f of x1 is equal to f of x2, equate that, and at the end, if you yield x1 is equal to x2 as the only solution, then the function is 1, 1, otherwise it is many 1. Okay, we already, you know how to do that. Okay, it's a very basic thing. But there is another concept also, that is, let's consider an interval here, that is minus a to b. Okay, see, if in this interval, if the function is either increasing or in a particular interval, if the function is decreasing, then the function is 1, 1 in that interval. Okay, if the function is increasing or decreasing in a particular interval, then the function will be 1, 1 in that interval. For on to, we need to go for other checking like that. Okay, that I can explain later. Okay, so let's formulate the function here, that is f of x is equal to 2 raised to x minus f of x is equal to 2 raised to x minus 2 raised to minus x divided by 2 raised to x plus 2 raised to minus x. Okay. We need to differentiate it. Before that, we need to simplify the function. So, it will be like f of x is equal to 2 raised. How are you going to simplify this one? See, I know you can differentiate it but using quotient rule and all. But if you made a slight adjustments here, the function becomes more easier. Function will be in more compact form and it will be more easier to differentiate that. So, how are you going to differentiate, going to modify this? It's very easy actually. I'll show you how. Here we have 2 raised to x plus 2 raised to minus x, right? So, I'm going to write this here, 2 raised to x plus 2 raised to minus x minus 2 into 2 raised to minus x. That is 2 raised to x minus 2 raised to minus x divided by 2 raised to x plus 2 raised to minus x. Okay. Then individually divide it and you will get 1 minus 2 into 2 raised to minus x divided by 2 raised to x plus 2 raised to minus x. Okay. One more thing, multiply here and here with 2 raised to x. Becomes more easier. That is 1 minus 2 divided by 2 raised to 2x plus 1. See, became more presentable. Okay, so we need to find f dash of x. So what is f dash of x? This becomes 0, which is equal to minus 2 into, this will comes on top, that is 2 raised to 2x plus 1 the whole raised to minus 1. 2 raised to 2x plus 1 the whole raised to minus 1. What is the derivative of that? into minus 1 into 2 raised to 2x plus 1 the whole raised to minus 2 into 2 raised to 2x log 2 into derivative of this one, that is 2. So, this will be 4, right? That is minus 2 into minus 1 into 2, that is 4. 4 log 2 divided by 2 raised to 2x plus 1 the whole square into 2 raised to 2x. Okay, I hope you are getting the idea here. And f dash of x. So, which function is this f dash of x? Is it an increasing function or decreasing function? See, f dash of x is greater than 0, right? See, this is greater than 0, this is greater than 0, this will always be greater than 0, this will be greater than 0. So, for whatever value of x, f dash of x is what? Greater than 0. What is the meaning of that? F of x is which function? An increasing function in all real numbers, for all real numbers. That is, for all real numbers, f of x is what? It just keeps on increasing. Okay, therefore, f of x is increasing from minus infinity to infinity. Okay. Now, we are going to use a very useful concept here. Okay, just listen. What is f of x? You can use this one. F of x is equal to 1 minus 2 by 2 raised to 2x plus 1. Okay, f of x is equal to 1 minus 2 by 2 raised to 2x plus 1. Okay, so we know that, see, if it is minus infinity and infinity here, f of x just goes on increasing. Okay, that is will be like this. So, minimum value is for minus infinity and maximum value hits when x is equal to infinity. We can substitute both the values here. Let's see what happens. What is f of minus infinity? That is 1 minus 2 by 2 raised to minus infinity plus 1. See, 2 into minus infinity is minus infinity. So, what is 2 raised to minus infinity? 1 by 2 raised to infinity. What is 1 by 2 raised to infinity is 0. Okay. So, 0 plus 1 is what? 1 and 2 by 1 is 2 and 1 minus 2 is what? Minus 1. Okay. And what about f of infinity? For that, I think we need to move to the next slide, that is f of infinity. Okay. F of infinity is equal to 1 minus 2 by 2 raised to infinity plus 1. 2 raised to infinity plus 1. Okay. 2 raised to infinity is infinity, infinity plus 1 is infinity, 2 by infinity is what? 0, 1 minus 0 is what? 1. Therefore, f of minus infinity is equal to minus 1 and f of infinity is equal to what? 1. So, the value of the function is shuttling between open interval minus 1 to 1. Okay, so that is the range of the function. Okay, so what was the codomain? The codomain was minus infinity to 1, right? The codomain was minus infinity to 1. Okay, this is the codomain and this is the range. Is range is equal to codomain? No, absolutely not. Okay, therefore, the given function is what? Not onto, therefore, it is an into function. Okay, and as I already mentioned, the function is increasing in which interval? Minus infinity, infinity, and for that interval, the function will be what? 1, 1. Okay, so the function is 1, 1 but not onto. Okay, that is 1, 1 into. 1, 1 but not onto. Okay, fourth option is the correct one. Okay, a concept oriented question. Okay, just go through this question one more time. Okay, so this method, if the function is increasing, I have calculated the range of the function based on the nature of the function. Okay, and by that I got the value of the function as minus 1 to 1. The range is minus 1 to 1. Okay, this is another method of finding the range. Numerous method for finding the range is there. Okay, depending on the condition as well as question. Okay, hope you got the idea here. Then the next one, next question. Okay, mod x represent greatest integer less than or equal to x. Okay, I will call it as box x. Okay, greatest integer x is equal to box x. That's more easy to tell and convey. Then you need to find the domain of f of x is equal to sec inverse of 2 times box x plus 1. Okay, so what is the domain of sec inverse of x? Closed interval 1 to infinity union minus infinity to closed interval minus 1. Okay, in the reverse order. Therefore, the domain of sec inverse of x is like minus infinity to minus 1, union closed 1 to infinity. Okay, let's operate both of them separately. Okay, that is 2 times box x plus 1 greater than or equal to 1. Okay, that is closed interval 1 to infinity means greater than or equal to 1. Okay, this got cancelled. That is 2 times box x greater than or equal to 0. That is 2 times box x greater than or equal to 0. That is box x greater than or equal to 0. Okay, so which values does x can take so that box x is greater than or equal to 0? Closed interval 0 to infinity. You know that x element of closed interval 0 to infinity. Okay, this is done. Next one. That is 2x plus 1. 2 into box x plus 1 less than or equal to minus 1. Okay, so this becomes 2x less than or equal to minus 2. 2 got cancelled and becomes x less than or equal to what? Minus 1. How are you going to solve this one? X less than or equal to minus 1. So let's, if you have any confusion, let's start from the figure here. Okay, 0, minus 1, 1, minus 2. Okay, which value x can take so that mod x is, box x is less than or equal to minus 1? See, if you start from here, the box of value in here is what? 0. What is box 0? 0. What is box minus a number which is lying between minus 1 and 0? That is, what is the value of box minus 0.1? Minus 1. Therefore, we can take values starting from 0 and not excluding 0. Okay. Therefore, x element of what? Minus infinity to 0. Okay, open 0. See, this is where the problem gets more interesting. Okay. So, basically, x should be either this or this. Okay. That is either this or this. That is x element of closed interval 0 to infinity or x element of what? Minus infinity to 0. That is minus infinity to 0. So, if you look closely, that is all real numbers. This is covering all negative real numbers and this is covering all non-negative real numbers. Therefore, in short, it will be minus infinity to infinity. Okay, or means union. You need to club everything. Okay, very easy question. And option number 3. Okay, there is one more option here. Okay, 0 if you substitute here, there is no issue. For questions like this, I will tell you a shortcut. Okay. See, first take this option 0 or take this one minus 1 minus infinity to minus 1 union 0 to infinity. Okay. Tell me a number between minus 1 and 0. That is minus 1 by 2. Okay. Substitute minus 1 by 2 here. What will you get? What is that is sec inverse. What is box of minus 1 by 2? What is box minus 1? Box of minus 0.5. Minus 1. What is minus 1 into 2? Minus 2. What is minus 2 plus 1? Minus 1. Is it valid or not? It is valid. Okay. It lies in the domain. Therefore, this is not correct. Okay. Then this is also not correct because minus 1 by 2 is not included there. Okay. Then two options are left. Go for this one. They have excluded 0 here. Substitute 0 here. Let's see what happens. What is box 0? 0. 2 into 0. 0. Plus 1. 1. Therefore, sec inverse 1. What is sec inverse of 1? It's valid. You don't have to find the value. You just need to check whether sec inverse of 1 exists or not. Is defined or not. It is defined, right? Therefore, this is also not correct. What is the correct answer? This one. Okay. Sometimes, very rarely, this method helps. Okay. And next one. Okay. All of you should know this function, right? It's in your NCERT textbook. Okay. F of x is equal to represented by 4x plus 3 divided by 6x minus 4. X is not equal to 2 by 3. And f of x is equal to g of x. The domain and codomain of g is given. Then g of 4 is equal to. A very direct question. See, it's in your NCERT textbook. Okay. So what is f of x? That is 4 into f of x plus 3 divided by 6 into f of x minus 3. Okay. That is, substitute this here, you will get 4 into 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 into 4x plus 3 divided by 6x minus 4 minus 4. Okay, here we have minus 4. Okay, sorry. Minus 4. Okay, see if you operate it, you know how to simplify this, right? You'll get x. I'm writing it directly because it's an exercise, it's a very basic question, okay, and it is a familiar expression of a function, okay. Therefore, f of x is what? X, that's all. That is f of x is equal to x. Therefore, what is g of x? That is x. Okay, therefore, what is g of x? X. What is g of x? That is x. That is, what is g of x? That is g of x, that is x. And what is g of x? That is equal to x. Then what is g of 4? That is 4. That's all. Okay. A very easy question. Okay. And highly time saving question. And next one. Okay. An interesting one. F of x is equal to x raised to 5 plus 2x cube plus 3x plus 1. X is the element of R. And g of x be a function such that g of f of x is equal to x for all x element of R. Then you need to find g of 7 divided by g dash of 7. Okay. How will you find g of 7 actually? What is g of 7? That is, f of x should be 7. There should be some value for x so that f of x is equal to 7. Only then it will hit 7, right? That is, we need to convert g of f of x is equal to x in term like this. Okay, that is, f of x should be equal to what? 7. That is, this means that there will be some value of x for which f of x should be equal to what? 7. We can equate that value like this is equal to 7. That is, x raised to 5 plus 2x cube plus 3x plus 1 is equal to 7. Take this to the left hand side, it will be x raised to 5 plus 2x cube plus 3x minus 6 is equal to 0. So, for which value of x this equation is satisfied? Or we can formulate from here itself. There is no need of that. We can formulate from here itself. For which value of x this is equal to 7? 1, 2, 3, 5, 6. X is equal to 1. For x is equal to 1, this becomes what? 7. Okay, that is f of 1 is equal to what? 7. That's all. Therefore, g of 7. Okay, g of f of x is equal to what? X. So, to make 7 here, we need to put x is equal to 1. That is, g of f of 1 is equal to what? 1. That is, g of 7 is equal to 1. We have already formulated the numerator. Next, we need to differentiate this. Next slide. Okay, that is, we know that g of f of x is equal to what? X. Chain rule, apply chain rule here and differentiate, and you will get g dash of f of x into f dash of x is equal to what? 1. Therefore, g dash of f of x is equal to 1 by f dash of x. We need to make 7 here, right? Therefore, put x is equal to 1. That is, g dash of f of 1, that is 7, is equal to 1 by f dash of 1. Okay. So, what was f of x actually? X raised to 5 plus 2x cube plus 3x plus 1. F of x is equal to x raised to 5 plus 2x cube plus 3x plus 1. And what is f dash of x? 5x raised to 4 plus 6x square plus 3. And f dash of 1 is equal to 11, 14, right? That is equal to 14. Okay. So, we need to find g of 7 by g dash of 7, right? What is g of 7? That is 1. 1 by, what is g dash of 7? 1 by f dash of 1, that is 1 by 14, that is what? 14. So, 14 is the final cut answer for this one. A very easy question and doable also. That is 14. This one is the correct answer. Okay. Next one. Okay. let a function f defined from real numbers to real numbers defined by f of x is equal to 1 by x raised to 4 the whole raised to 1 by 4. Okay. And g of x is equal to f of x 3 1 2 3 4 f of x are there. Okay. Then 18 into 0 to root of 2 root 5 into x square into g of x is equal to. How are you going to do this one? Let's check it out. Let's find this first. Okay, only then we can proceed. See, g of x is equal to f of x, right? Let's find f of x. Okay, let's see if there is any pattern. Okay, in most cases there will be a pattern. Once you identify the pattern, you don't have to perform all of this. Okay, let's find f of x first. Okay, f of x. So this will be x by 1 plus x raised to 4 the whole raised to 1 by 4 divided by 1 plus, you need to instead of x we will have f of x, that is f of x raised to 4. This will be raised to 4, then this becomes x raised to 4 divided by, this will be 1 plus x raised to 4, okay, the whole raised to 1 by 4. It will be like this. Okay. Therefore, x by 1 plus x raised to 4 the whole raised to 1 by 4 divided by, this becomes 1 plus 2x square x raised to 4 divided by 1 plus x square the whole raised to 1 by 4. This is 4. Okay. And this got cancelled. And what is f of x? I think we have found the pattern here. That is x by 1 plus 2x raised to 4 the whole raised to what? 1 by 4. Okay. 1 plus 2x raised to 4 the whole raised to 1 by 4. 2 times f of x. So 3 times it will be x by 1 plus 3x raised to 4 the whole raised to 1 by 4. 4 times it will be x by 1 plus 4x raised to 4 the whole raised to 1 by 4. Okay. Okay. So we have formulated g of x and we need to find the integral of this one. Okay. Let's solve. It will be 18 into 0 to root of 2 root 5 into x square into x divided by x square into x square into x divided by 1 plus 4x raised to 4. 1 plus 4x raised to 4 the whole raised to 1 by 4. Okay. See, in some cases, if you are unsure of the pattern, just go for one more composition here. Okay, you can use f of x also here to get to the to get a proper idea about the composition of this one. Okay, the final product of this one. Okay. Let's solve here. So, how are you going to solve this one? I think it's very easy. That is 18 into 0 to root of 2 root 5 into x cube divided by 1 plus 4 x raised to 4 the whole raised to 1 by 4. Okay, easy one. Substitute this is equal to u, that is 16x cube. Okay, we can multiply here and here with 16 before that. 16 here and 16 here. Okay, let's put 1 plus 4 x raised to 4 which is equal to u. Okay, if you differentiate, you will directly get the numerator here. And we need to formulate for the upper limit and lower limit. The lower limit will be 1. And what about the upper limit? Upper limit will be, if you square it, you will get 2 root 5. Again, square it, you will get 20. And 20 into 4 is 80. 80 plus 1 is what? 81. So, it will be like 18 by 16 can be written as 9 by 8, 0 to 1, 0 to 81, sorry, 1 to 81. Okay, my mistake. 1 to 81 du divided by u raised to 1 by 4. This u raised to 1 by 4, when it goes on top, it will be u raised to minus 1 by 4. And if you integrate it, you will get u raised to 3 by 4 divided by 3 by 4. That is 9 by 8 into u raised to 3 by 4 divided by 3 by 4, 1 to 81. This got cancelled, becomes 3, this becomes 2. That is 3 by 2 into, what is 81 raised to 3 by 4? That is 3 raised to 4, the whole raised to 3 by 4, that is 27. That is 27 minus 1. Okay, what is 27 minus 1? 26. What is 26 by 2? 13. What is 13 into 3? 39. Okay, that is the final answer for this one. And the option is like fourth one. Okay, this is the correct answer. Okay, hope you got the idea here. The next one, next question. Very easy question. Let the function f of x is equal to 1 by 7 minus 5x be a function defined on R. Then find the range of the function. Just 1 minute question. Okay, we know that the value of sine, we can find the range of 7 minus 5x and take the reciprocal, you will get the range of that corresponding function. Okay, so it will be like, I am writing it as p. Okay, sine 5x as p, that is minus 1 less than or equal to p less than or equal to 1. Okay, let us assume sine 5x is equal to p. Okay, multiply it with negative and interchange the sign, it will be minus 1 less than or equal to minus p less than or equal to 1. Again add 7, it will be 6 less than or equal to 7 minus p less than or equal to what? 8. Take the reciprocal, it will be 1 by 8 less than or equal to 1 by 7 minus p less than or equal to 1 by 6. That is closed interval 1 by 8 to 1 by 6. Okay, very easy question. Okay. Hope you clear, hope it's clear. Okay, very basic question. Next one. Okay, the domain of the function. If the domain of the function given by f of x is equal to sine inverse of x minus 1 divided by 2x plus 3 is equal to r minus alpha beta, then you need to find the value of 12 alpha beta. Okay, let's do this. See, what is the value of what is the domain of sine inverse of something? Okay, the value should be between minus 1 and 1. Okay, whatever it is, if no conditions are mentioned, it should lie between this, what is inside the bracket should lie between minus 1 and 1. Okay, it is always like that. Okay, I am going to rub this because we need a lot of space for doing this one, some space for doing this one. Okay, so this one, x minus 1 by 2x plus 3, that is minus 1 less than or equal to x minus 1 by 2x plus 3 less than or equal to 1. Okay. So, we need to operate this separately. Okay, we cannot multiply everywhere with 2x plus 3 for obvious reason, because 2x plus 3 can be sometimes positive and negative depending on the value of x. Okay, we can do that by aligning other constraints and all, but it becomes more complicated. Okay, let's do it separately. Okay, I am going to do this one first, that is x minus 1 divided by 2x plus 3 minus 1 less than or equal to 0. Okay, cross multiplying you will get minus 2x. What is x minus 2x? Minus x minus 3, that is minus 4 divided by 2x plus 3 less than or equal to 0, that is x plus 4 divided by 2x plus 3 greater than or equal to 0. Okay, that's one thing. Next one, we can formulate this one. I haven't gone for the final answer. Okay, that we can do later. This one. Okay, I am going to interchange this. Therefore, this becomes x minus 1 by 2x plus 3 greater than or equal to minus 1. Okay, that is x minus 1 by 2x plus 3 plus 1 greater than or equal to 0. Okay, just add this, you will get 3x plus 2 divided by 2x plus 3 greater than or equal to 0. Therefore, two inequations are there. Okay, so if you got it like this, there is one thing which you need to consider here is, here we have numerator and denominator, same here also. You need to find the values where numerator and denominator becomes 0 for all the cases. Here for which value it becomes 0? Minus 4, and this minus 3 by 2, and this one minus 2 by 3, and this one minus 3 by 2 again. So, let us formulate from here. Let us draw a number line here. Okay, minus infinity, infinity. Let us mark the corresponding points in that order. Minus 4, okay, that should come first. Minus 4, minus 3 by 2, okay, minus 2 by 3. Okay, next one. So, for this to happen, which should be our corresponding division here. See, this now this 3 number line has divided the line into 4 parts. Okay, and we need to identify basically, see these two. minus 4 and minus 3 by 2. Minus 4 and minus 3 by 2. We need to consider this only for equating this one, for solving this one. These two numbers have divided the number line into 3 parts. We need to identify for which part it becomes positive and negative like that. Okay. So let's start. So we need to consider only two things here, minus 4 and minus 3 by 2 for this one. Okay, we don't have to consider about this one. Okay, for now. Let's consider minus 4 and minus 3 by 2. I am going to rub here. Okay, in case there is any difficulty for understanding. Okay. Okay, so tell me a number which is greater than minus 3 by 2. 0. If you substitute 0 here, what will happen? Do you get a positive number or a negative number? You get a positive number. Therefore, for every number, for the region which covers, which represents numbers which are greater than minus 3 by 2 will be yielding which value? Positive value. Therefore, positive value here. Okay. Can we take minus 3 by 2? We cannot take minus 3 by 2. If you take minus 3 by 2, denominator becomes negative and net value becomes not defined. So, we cannot take minus 3 by 2, but it will be from here to here. Tell me a number between minus 3 by 2 and minus 4, that is minus 2. If you substitute minus 2 here, this will be positive, this will be negative, net value will be negative. Therefore, we cannot take this value. And can we take 4? Minus 4, we can take minus 4, that is if x becomes minus 4, net value will be 0. Okay. Therefore, we can take minus 4. Can we take a number which is less than minus 4? Just substitute minus 5 here and here for x. You will get a positive value. Therefore, we can take that value also. Hope you got it. Like this, we need to formulate this one also. For that, we need to write another point, that is minus 2 by 3. Okay. Minus 2 by 3. And for here, we need to consider minus 3 by 2 and minus 2 by 3 only. That's for numerator and denominator separately becomes 0. Okay. We can use another ink here. Okay. Tell me a number which is greater than minus 2 by 3. 0. If you substitute 0 here, what will happen? You will get a positive value. Okay. So, can you use minus 2 by 3? If you substitute minus 2 by 3 here, this numerator becomes 0. That's valid. Okay. Therefore, it will be like we can include minus 2 by 3 and towards right. So, we can include all the region which covers greater than or equal to minus 2 by 3. So, tell me a number between minus 3 by 2 and minus 2 by 3, that is minus 1.5 and minus 0.6, minus 1. If you substitute minus 1 here, this will be negative and this will be what? Positive. Net value will be negative. We cannot take the value. So, tell me a number which is less than, can we include minus 3 by 2? We cannot include minus 3 by 2. So, tell me a number which is less than minus 3 by 2, that is minus 4. Okay. Or minus 2. If you substitute minus 2 here and here as well, it will be positive. Negative here and negative here. Okay. So the inequation structure is like this. So, we need to consider the inequality region which is satisfying both the conditions. Okay. Therefore, the region which is representing both of them, that is this one. That is, I will write it here. Okay. See, this is where there is a common region. Okay. This region and this region, that is minus infinity to minus 4. Should we include minus 4? Yes, minus 4 lies in this region and this region as well. Okay, union. This one. Okay, in both of them, the region is like minus 2 by 3 is common for that. That is closed interval minus 2 by 3. Okay, closed interval minus 2 by 3 to infinity. See, but the problem here is they have expressed the domain in another way. Real number minus alpha to infinity. Okay, let's express that. This can be expressed like, that is minus infinity to minus 4 union closed interval minus 2 by 3 can be also expressed as real number difference minus 4 to minus 2 by 3. So, this is alpha and this is what? Beta. You need to find 12 alpha beta, right? That is 12 into minus 4 into minus 2 by 3. This got cancelled, becomes 4. 4 into 4 is 16, into 2 is 32. Positive 32 is the answer. Okay, interesting question and doable also. Okay, 32 means option number 1. That's the correct one. Okay, I hope you got the idea here. Next one. Okay, another question from domain. Okay, if the domain of the function is given by root x square minus 25 by 4 minus x square and log x square minus 2x plus 15 to the base 10, is minus infinity to alpha union closed interval beta to infinity, then you need to find the value of alpha square plus beta cube. How are you going to do this one? See, let's break this. Let's take this as g of x and take this as h of x. Okay. And let's assume the domain of g of x is d1 and the domain of h of x is d2. Okay. See, if two or more functions are expressed like this, you need to find the domain separately and you need to find the intersection of all of those domains. Only then you will get a proper answer. Okay. So let's find the domain of this one first. It's easy actually. That is d1. I'm going to find d1 here. Okay. That is root x square minus 25 divided by 4 minus x square. So what's with the numerator? Root of x square minus 25. That is x square minus 25 is greater than or equal to 0. Should be greater than or equal to 0. So this is an expression which is frequently asked in +1 board examination. You know how to do that. Therefore, x will be element of minus infinity to minus 5 union closed interval 5 to infinity. Okay, there is one thing also which we need to consider. 4 minus x square, that is 4 minus x square not equal to 0, that is x not equal to plus or minus 2. Okay, I forgot to add one thing which is like g of x can be further classified as this and this. So if you want to get the domain d1, you need to find the domain of this one and this one separately and take the intersection of that. Okay, sorry, I forgot to mention that. Okay, you need to find the domain of this one and this one separately and you should take the intersection of that. So what is the intersection of these two? What is the intersection of these two? You cannot take x is equal to 2. Okay, this is x not equal to plus or minus 2. So we are safe here because plus or minus 2 is not included here. Therefore, we don't have to give much concern about that. So what is the net domain here? X element of close to minus 5 to minus infinity union close to 5 to infinity. Okay. Next one. Okay. So in here, the value should be greater than 0. That is x square plus 2x minus 15 should be greater than 0. Okay. One method is like we can convert this partial into a perfect square. That is x square plus 2x plus 1 greater than 16. That is x plus 1 the whole square greater than 16. That is x plus 1 greater than 4 or x plus 1 less than minus 4. Okay. If x plus 1 greater than 4, then x is greater than what? 3. Here x is less than what? Minus 5. Okay. And we need to consider the common region. Therefore, we need to draw a graph here that can be arranged. That is, we need to plot every points here like minus 5, 3 and minus 5, 3 and what? 5. Okay. Closed interval minus 5 to infinity means minus this to here and here to here. Okay. Greater than 3 means greater than 3 and less than minus 5. Okay. Greater than 3 means another ink. Greater than 3 means from here to here and less than minus 5 means from here to here. Okay. Just observe what is common in these two regions. If you want, just pause the video and identify what is common in these two regions. See, minus 5 is in here, but it is not in here. Don't include minus 5. Okay, other region is here, therefore it will be minus infinity to minus 5 union. Okay, here we have, I think, yeah, here we have 5 and here also we have 5. So it will be closed interval 5 to infinity. Okay, so what is our, okay, that is alpha square plus beta cube. That is, this is alpha and this is beta. So you need to find alpha square plus beta cube. What is alpha square? 25. What is beta cube? 125. What is 25 plus 125? 150. Okay. Good question. Basic one, but interesting. Okay. Next one. A very easy one. The function f defined from natural number minus 1 to natural numbers. Domain is all natural numbers except 1 and codomain is natural numbers. Defined by f of n is equal to highest prime factor of n. Okay. You need to identify the injectivity and surjectivity of the function. Okay. That is whether the function is 1, 1 or many 1 or on 2 or n 2. Okay. How are you going to formulate this one? It's a very easy question actually. See, f of n is the highest prime factor of n. We cannot take n is equal to 1. Okay, that is mentioned there. So what will be f of 2? What is the highest prime factor of 2? 2. And what is f of 3? What is the highest prime factor of 3? 3. And what is f of 4? Highest prime factor of 4? 2. Prime factor. 4 is a factor, but we cannot take 4 because it should be a prime factor. See, already it is the answer. Okay, have you formulated what is the answer here? It's done. The problem is done. It's over. See, for f of 2 and f of 4, we are yielding a same value, same output here. Therefore, for some values for in the domain, we are getting same values in the codomain. Okay, for the function. So the function is what? Many one. Okay, that is many one. That is many one. Okay, and what about onto into? It will be into. Why? Because 1 is in the codomain. It is never been used and we are never going to use it because 1 is neither prime. 1 is not a prime number. Okay, therefore it is an into function. That is neither 1 1 nor onto. Okay, that is many one into. Done. Next one. Okay, A is equal to ordered pair xy such that 2x plus 3y is equal to 23 and x comma y element of natural numbers given, and B is equal to x such that ordered pair xy element of A. That is, B should be the first component from all the elements in all the ordered pairs from set A. Okay, let's formulate. I think it's an easy question. That is 2x plus 3y is equal to 23. Okay. Okay, let's solve. Put y is equal to 1. Y is equal to 1. That is, y is a natural number. Y and x are natural numbers. Put y is equal to 1. You will get, it will be 3. What is 23 minus 3? 10. What is 20? And 2x is equal to 20. X becomes what? 10. The one thing is, you cannot put y is equal to 2. If you put y is equal to 2, it will be an even number. This is an odd number. An odd number minus even number will be an odd number. Okay. See, 2x should be an even number. Okay, therefore we need to put the next value, next odd number, that is 3. Okay, see, things like this will dilute the method of solving the questions. Okay, so 3 into 3 is what? 9. What is 23 minus 9? 14. 2x is equal to 14, that is x is equal to what? 7. There is a pattern here. Okay, that is 5, 15, 12. This is 6, 10, 7, 15 minus 23 is 8. Okay, that is 4 here. Okay, that is 10 minus 3 minus, this is 1 and this is 7. If this is 1, y is equal to 7, 21 and x equal to 1. Okay, therefore the ordered pair will be like 10, 1, okay, 7, 3, okay, 4, 5 and 1, 7. Okay, this is what A is equal to. And what about B? B is equal to 10, 7, 4, 1. Okay. So, we need to find the number of 1, 1 function from A to B. It's done. There are 4 elements here and 4 elements here are here as well. Therefore, it is a number of ways of arranging these 4 elements in here. That is 4 factorial. 4p4, that is 4 factorial. That is what? 24. Okay. A very easy question. Next one. A is equal to, very interesting one. Mod 2a minus 1 is equal to 3 into box A plus 2 into fractional part of A. Okay. And then 72 into A element of sigma, A element of S. That means you need to find all solutions of A from here and we need to sum that up and we need to multiply that with 72. Let's try. See this modulus, okay, before that, mod 2a minus 1 is equal to 3 times box A plus what is fractional part of A? That is A minus box A. That is, if you multiply it with 2, you will get 2 minus 2 into box A. Okay, that is mod 2a minus 1 is equal to 2 plus box A. Mod 2a minus 1 is equal to 2 plus box A. And we need to operate this one next. Okay, that is for the value will change. That is if A greater than 1 by 2, A greater than 1 by 2, then it will be just 2A minus, this is 2A. Okay, that is 2A minus box A. That is here also we will have 2A. That is for a greater than 1 by 2, this will be 2a minus 1. That is 2a minus 1 is equal to 2a plus box a. Okay, got cancelled and box a becomes minus 1. There are values of a for which box a is equal to minus 1. But the problem is like we have already provided a condition here. That is a greater than 1 by 2. Okay. See, a value for a which satisfies both the conditions is not there. Okay. Therefore, this is not valid. We need to move to the next one. That is a less than minus 1 by 2. A less than minus 1 by 2. That is, this becomes 1 minus 2a. That is 1 minus 2a is equal to 2a plus box a. That is 2a plus box a. Okay. That is 1 minus box a is equal to what? 4a. How are you going to solve this question? See, if it is a linear equation or a quadratic or a cubic or even a quartic, we can do this. But how are you going to do this one? We need to apply slight logic here, like see, for whatever the value of a less than 1 by 2, okay, a less than 1 by 2, whatever the value of a, this is an integer, right? And 1 minus an integer becomes an integer. So, practically the LHS is what? An integer. And we need to find the values of a for which the right hand side becomes an integer, and we need to apply try and error method. Hopefully we'll get the we will get the answer soon. Okay. Is there any restriction for a? A is element of real numbers. Okay. So let's start with 0. If a is equal to 0, then RHS becomes, let's put RHS and LHS here. Okay. RHS is what? 0. And what about LHS? 1. 1 minus box 0 is 1 minus 0, that is 1. Tell me any other value which makes here, makes an integer here. 1 by 4, right? If a is equal to 1 by 4, this will be equal to 1. Okay. That is 1 by 4, this is equal to 1. And if a is equal to 1 by 4, what is box 1 by 4? Box 1 by 4 is 0. What is 1 minus 0? 1. Okay. See, it is 1 here. Okay. If a is equal to 1 by 4, this is equal to 1. So, it's matching, right? A is equal to 1 by 4 here and here is matching. Okay. Therefore, 1 by 4 is the correct answer. Okay. A is equal to 1 by 4. Will it match? Is it matching here also? See, a is less than 1 by 2. Okay. 1 by 4 is a value which is less than 1 by 2. Okay. So, it is the final value. A is equal to 1 by 4 is the final value. Only one value is there. Therefore, there is no need of summing it up. Okay. Therefore, the final result will be 72 into what is the value of a? 1 by 4. So, the net result will be 18. Okay. So, that's it. That's it for today's session. We have discussed so many questions and numerous concepts and shortcuts and like that in this session. Okay. Thank you for listening till the last question. Okay. Hope you got the idea here. Just go through these questions one more time. Okay. To get a proper idea of this topic. Okay. So, let's meet again in the part 2 of this functions. Okay. Take care.